It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Good morning, my dear students. Good morning. Welcome to the most reputed platform, Unacademy. My dear students, okay, myself is Dr. B.N. Rao, having purely 17 years of the teaching experience I had, my dear students. Okay, let me introduce myself. 17 years of the pure teaching experience I had, my dear students. Out of this pure academic experience from the last 10 years, my were students, I was teaching the various subjects. Okay, at the gate and engineering services level in the departments of electronics and communication and instrumentation engineering. The subjects like communication systems, core instrumentation, electronic devices, and VLSI design, my dear students. Okay, out of these 17 years, 10 years I was dedicated to the competitive level parallel experience, my dear students. Okay, and nearly I dealt 200 plus batches across all the locations of the country, my dear students. Okay, good morning Venkatesh, good morning Pranavi, Nagul Meera, Kirtana, Vaishnavi, Vishwaksena, okay, Sai Santosh, Akil, Badri. Good morning, my dear students. Okay, to each and everyone. Okay, moreover, I mentored nearly 10,000 plus students across all the locations of the India, my dear friends. When how to crack the government job, whether it is a central government job or state government job, based upon these particular competitive level examinations are getting the seats and the NITs or IITs, my dear friends. I mentored across all the locations of the India in the form of the webinars and seminars, my dear friends. Okay, similarly, the very important thing just I would like to bring it to your notice itself is that in academic engineering college also I dealt 15 plus subjects. Okay, 15 plus subjects. Okay, out of my particular pure experience, my dear students. Okay, out of my particular pure experience, my dear students. Okay, very important points. Just I would like to bring it to your notice over here. Similarly, as well as Unacademy, welcome to the most reputed platform Unacademy, my dear friends. Out of these particular platforms, two important subscriptions are there. One is Iconic and second one is Plus subscription. Okay, as far as the Iconic subscription is concerned, my dear friends, good morning Vanilla, good morning Badri. Iconic subscription is concerned, a personal coach is dedicated, my dear friends, for each and every student regarding the subjects at the GATE and engineering services level. Each and every subject expert will explain with a detailed study planner, that is starting with the basics, followed by concepts, derivations, and level 1 numericals, level 2, level 3 numericals, and previous year questions, my dear students, also from 1987 to the 2020. Moreover, you are going to receive the expert guidelines also from the other educators as well as Unacademy is concerned, my dear students. Okay, similarly, okay, when it comes to the engineering services level, mains level guidance also, my dear students, you are going to get over here. Okay, at the preliminary level and at the mains level, my dear students, as far as Unacademy is concerned. Okay, good morning Vanilla, good morning Saitij, Satyajit, good morning everyone. When it comes to the Plus subscription also, my dear friends, when you are going to take this particular subscription, you are going to access the live classes from the topmost educators of the Unacademy over here. Moreover, you can practice unlimited test series with respect to the live classes from the topmost educators in whatever the medium you are expecting, whether it will be English or whether it will be, my dear friends, the English plus Telugu or English plus Hindi. You can go for all the faculties and access the various subjects for the GATE aspirants of 2022, my dear students. Okay, very important. Okay, here also a detailed structured timetable is present over here, my dear students. Okay, very important points. Just I would like to bring it to your notice. Similarly, the Unacademy subscriptions, my dear students, I am going to bring it to your notice itself is the GATE and engineering services for Plus subscription for 12 months, 27,225, and you can use my code and get the discount. Okay, similarly for GATE and engineering services from same Plus subscription 34,650, and you can use my code and get the discount. Okay, for GATE and engineering services for the same Plus subscription for 24 months 39,600, and you can use my code and get the 10% discount, my dear students. Okay, good morning Shravani, Suryamani. Similarly, my dear friends, the very important thing itself is that now when it comes into the Iconic subscriptions for GATE and engineering services for 12 months 45,225, and you can use my code and get the discount. Okay, similarly for GATE and engineering services for the same Iconic subscription for 24 months 66,600, and you can use my code and get the discount over here. Similarly, the biggest ever surprise, my dear students, that is a new year gift, that the Unacademy GATE Telugu channel has been transformed into the Unacademy GATE English channel for the GATE aspirants of the 2022, my dear students. Please access it. New batches has been started. Okay, new subjects have been started from this particular February month also, my dear students, in the YouTube free classes. You please utilize it, my dear students. Okay, you please utilize it, my dear students, over here. Okay, good morning Shravani. Okay, similarly, my dear students, from 18th of the January, the electrical batch has been started. The faculties who are going to teach you the inside of the Unacademy subscription and the most respective faculties and the batches in the month of January. Spark batch for GATE 2022 aspirants, which will be taught in English, already starting for electrical in the month of January. Okay, similarly Spark batch for GATE 2022 ECE, the medium of communication is English, my dear students, over here. Okay, very important points. Just I would like to bring it to your notice over here. Okay, good morning Venu. Similarly, there are batches that has been started, my dear students, in the same month of the January, starting from 18th of the January. That is also for GATE 2023 electrical, my dear students. Okay, similarly, okay, good morning everyone over here. Similarly, for GATE 2023 ECE, my dear students, 18th of the January, there are certain batches that has been started, my dear students, over here. Okay. Similarly, my dear students, in the month of the February, there are certain batches that has been started, my dear students. Okay. Good morning everyone. Good morning Marikanta Reddy. Good morning Durga Prasad. Okay. Good morning everyone. So from the 1st of the February, the batch for Ascend for GATE 2023 EC batch started. Similarly, Evolve for GATE 2022 EC batch started, my dear students. Similarly, Ascend for GATE 2023 electrical batch started, my dear students. Good morning Pooja. Good morning Sunny Reddy. Good morning everyone. Similarly, Evolve for the GATE 2022, my dear students, this particular batch also started. Okay, in the month of the February, there are certain batches that has been started in the month of the February, that is Ascend and Evolve for the EC and electrical departments, my dear students, where you can go for the various subjects, my dear students, over here. Okay, good morning everyone. Good morning Pooja, Sunny, Harsha. Okay, good morning Deepika, Yogesh, everyone, my dear students. Okay, for the today's class. Okay, and January month schedule already, my dear students, the January month schedule already it has been finished, my dear students, and it is running successfully over here. Okay, and it is running successfully over here, my dear students. Okay, and the February month schedule also it has been started. Please go for, my dear students, the very important, okay, over there. Okay, over the Unacademy English channel. Very good morning, my dear friends, everyone, Yogesh. Okay, to each and every students, Naveen, each and every students, my dear students. Okay, that's what I'm going to tell you. So these are all the important things. Just I would like to bring it to your notice over here. Okay, similarly, array subsystems. Okay, we have started the continuation of the previous session. The continuation of the which session, my dear students? The previous session. Okay, very important points. Just I would like to bring it to your notice. In the previous session, I have started, my dear students, about the DRAM. Okay, SRAM is completed. Now DRAM. We are entering into the DRAM, my dear students. Okay, dynamic RAM, my dear students. Okay, what is the difference between the static RAM and dynamic RAM, my dear students? I already told you. Okay, what is the difference, my dear students, between the static RAM and dynamic RAM? Okay, so in static RAM, it holds the data. Okay, static RAM holds the data as long as power is applied. As long as power is applied, power it holds the data. But in dynamic RAM, my dear students, here what happens? It must be here. What happens? Loses the data when the power is removed. Okay, it loses the data when power is removed, my dear students, in dynamic RAM. Okay, and in dynamic RAM, dynamic means it must be refreshed periodically. It must be refreshed periodically, my dear students. Okay, it must be refreshed periodically, my dear students, by using the refresh circuit. I told you in the previous class, my dear students, all the concepts. Okay, and my dear students, always the SRAM is faster and less volatile. So SRAM is faster and less volatile than the dynamic RAM. Okay, less volatile means here what happens? The data immediately it has been lost. Okay, in SRAM. Okay, now in the last class I told you, my dear students, the very important thing regarding the what are the various types of operations we are going to do in dynamic RAM. I told you what is dynamic RAM. Okay, why the term dynamic comes for a RAM, why, how to do the, okay, the how to make the data periodically we are going to be, okay, changing by using the refresh circuit. And I told you, my dear students, in the previous class regarding what is that is one transistor DRAM cell, how it is there, and how the DRAM operation is taking place, my dear students. I told you in the previous session. Similarly, one transistor DRAM write operation, I told you in the previous class. Finished, my dear students, in the previous class. Similarly, I told you about the hold operation, my dear students, in the one RAM, that is one transistor DRAM cell, in the last class. Similarly, my dear students, I have finished about the one transistor DRAM cell hold operation. Up to here, I have finished in the last class. I had finished, my dear students, up to here into the last class over here. Okay. Now, my dear students, we are going for the some more operations which can be performed. Okay. The very important is that in DRAM cell, the word D stands for. Okay, here what happens? The D is dynamic. Dynamic means data must be refreshed periodically. So how the refresh operation is going to be happening, my dear students? Okay, that is also very important. Okay, from that, so that particular concept we are going to start in this particular class. Okay, how the refresh operation is going to do, my dear students, here. Okay, how the refresh operation is going to be taking place, my dear students. Okay, in a one transistor. Okay, that is one transistor DRAM cell. Okay, one transistor DRAM cell, how the refresh operation is going to be taking place. Okay, here what happens? The first point you have to remember is that it holds the data. The DRAM, my dear students, it holds the data as power is applied. Okay, it is holding the data as long as the power is applied, and the data must be refreshed at that time only. Okay, so here what happens? It holds the data when power is applied. When power is applied, my dear students, and here automatically what happens? During this particular time only, the data must be refreshed. The data must be refreshed, my dear students. Okay, during that particular time only, the data must be refreshed. Ardhamaindana, it is holding the data. So it is holding the data, my dear students. So the power is applied only. That we know. But when the refresh operation is going to be done means whenever the data holds, whenever the power is applied, at that time only you can perform the data must be refreshed. Okay. How we are going to make the data? Okay. How we are going to be the refresh operation is going to be executing, my dear students. First listen. Okay. First listen, my dear students. Okay. Suppose I am going to take it a NEO dynamic RAM figure. Listen carefully. I am going to take it, my dear students. Very important, a simple thing. Okay, over here. A simple one dynamic RAM. If it is a dynamic RAM, my dear students, listen carefully. What I am going to explain, very important. How the refresh operation is going to be executing, my dear students, on this particular one. Today's concept is very important, my dear students. Okay, very important, my dear students. Okay, good morning, Amulya, Shivani, Amulya. Okay, everyone. Good morning, everyone. See here. See here, my dear students, how the refresh operation is taking place over here. Very important, my dear students. See, if I am going to take this is a DRAM. If it is a DRAM, my dear students, in the DRAM, the memory cells are there. The memory cells are there. These are all the various types of the memory cells, my dear students. Okay, these are all the memory cells. various types of the memory cells are there, my dear students. Okay, and all these particular memory cells, what I am going to do, first select the cells to execute the refresh operation. First we need to select the cells. Okay, select the cells, my dear students. Next, first the data should be refreshed on this DRAM. So the data should be refreshed on this DRAM means first what I have to do, the data should be present. The data should be present. Data ikkada undal kada. Then what happens? First read the data bits. Then read data bits. Okay, read data bits, my dear friends. And whatever the data bits you have been, okay, read that, restore it. Restore the values. Restore the values because we want to erase the data periodically. Restore that particular data, my dear students. Then what happens, if because DRAM we are going to perform the two duties, one is the reading and second one is the writing. Okay, and rewrite the bits. Rewrite bits, my dear students. Okay, rewrite the bits over here. Okay, every time, okay, for rewriting of the bits we need to select the select, that is we need to select the cells. That's the reason there is a connectivity between this one and this one. There is a connectivity between this one and this one, my dear students. Okay, very important point that you need to remember over here. Okay, very important point, my dear students. Okay, here what ultimately I am going to tell you here. See, first point is that see, the data must be refreshed when means when power is applied. It then only it holds the data. During the holding situation only the data must be refreshed. How we are refreshing the data means first we need to select the cells, then we have to read the data in that cells. Okay, and the data that should be present, what are the existing data that is present, first read it, then restore it. Okay, then after restore it, if you want to write down any particular data, that also you can write it. Okay, then what happens, my dear students, the data should be periodically we are going to be taken out, my dear students. Okay, so here was the data must be refreshed. Okay, so what happens, so here what happens, when you want to read the data, restore the values or rewrite the data, every cell, okay, every cell we need to do what, amplification. Okay, amplification, my dear students. Okay, so amplify the cell data also, very important. Amplify cell data. Okay, cell data, my dear students. So first we have to take a memory cell. Amplify means every cell will be, okay, will be receiving the correct power or not, wherever every cell in the memory is okay, good with strength or not, that is nothing but amplification. Next, the rewrite the data to the cell or refresh. Okay, the refresh, my dear students. Okay, here the very important is that we are refreshing periodically the dynamic RAM. The D stands for what, my dear students? The dynamic. Okay, D stands for dynamic, means refreshing. Okay, so here very important is that see, what is the refresh frequency? Okay, what is refresh frequency, my dear students? Okay, this is also very important point. Just I would like to bring it to your notice over here. Okay, what is refresh frequency? The frequency, my dear students, very important point. This point also, listen carefully. The frequency at which, my dear students, okay, at which, what is refresh frequency? Okay, the refresh frequency means the frequency at which the cells must be refreshed to maintain data. Every time it, see here we cannot store the long amount of data. Every time we are going to be refreshing. See here, what is refresh frequency means frequency at which cells must be refreshed. Refreshed to maintain data. My dear students, okay, to maintain data, and there is a relationship between the refresh frequency and hold time. Okay, very important is the hold time, and that is nothing but TH. Okay, see here, The refreshing depends on hold time is, yes, definitely. See how much, see the time the data is present inside the memory cell is very important, and that one is nothing but the hold time, th. Okay, and here the data that must be present inside this hold time depends on frequency, because every time we are going to refresh. Okay, so ultimately, see, the hold time is depending on the frequency only. Okay, the hold time is depending on what, my dear students? It depends upon the frequency only. So ultimately here the refresh, the relationship is f refresh, my dear friends, which is equal to 1 by 2 power of th. Okay, hold time. Good morning Jansi, good morning Rahul. th, my dear students. Okay, that is hold time, my dear students. Okay, so always to do the refresh, okay, refreshment, that is always to refresh the memory. What kind of thing we are going to use? A refresh circuit. Okay, to refresh the memory we are going to use the refresh circuitry. In time in DRAM, in dynamic RAM, my dear students. Okay, we are going to be refreshing, my dear students, the circuitry in the dynamic RAM. Very important point. Just I would like to tell you, in the previous class I have explained some operations. Okay, now in this particular class I am going to explain the some more operations, my dear students. Okay, similarly how I am going for the hold operation is over, hold time operation is over, now DRAM operation is over, my dear students. I told you in the previous class regarding the write operation. Now how to read the data, my dear students, that is also very important over here. Okay, how to read the data, my dear students, here also listen carefully. How to read the data, my dear students, very important over here. Okay, now here what happens, my dear students? I am going to take it here also like this. Good morning Sushmita. See here, my dear students, very important is that see, we are reading the data. I want to read the data on the memory. Suppose I have taken the memory, this is a general memory. If I am going to take it, whether I want to read ones or zeros, I want to read the ones or zeros, my dear students, on this particular DRAM. Ones or zeros, my dear students. Okay, on this particular DRAM, how it is taking place, how to read the data. This is the internal architecture, my dear students. Okay, here very important. This one is called C bit. This one is called what, my dear students? C bit. This is bit line capacitance. Okay, here this is word line. Keep the word line is always connected to 1, my dear students. Okay, similarly here the storage capacitance, the voltage across the storage capacitance is storage voltage, my dear students. Very important over here. Okay, similarly now I am connecting this one to the very important is the voltage. For bitline voltage, the applying voltage is, for bitline capacitance I am applying the voltage. This is C bit, means bitline capacitance. I am applying the voltage, and that one is V bit. This is plus or minus, my dear students. Okay, V bit voltage we are applying here. First turn on the compute, turn on this particular transistor. On this transistor, first point is that turn on this particular transistor, my dear students. Okay, first one is that one. Okay, I am writing here the points, very important points. Okay, first turn on the access transistor. This is the transistor where I want to access it. Okay, turn on access transistor, my dear students. Okay, second point itself is charge on CS. Okay, now charge on CS, my dear students, with respect to the bitline capacitance. Okay, with respect to the bitline capacitance. See here, second one is charge on the CS. Okay, here the bitline capacitance here. If C bit, the bitline capacitance C bit is logically 1. Okay, if it is I am going to given 1, my dear students, very important is if C bit is 1, my dear students, then what happens is charge on CS. Okay, there will be a charge on CS, charge on the CS, my dear students. Okay, charge on the CS. So then automatically what happens, whatever the bitline voltage, okay, that is also, this is what, this is bitline capacitance. C bit is what, my dear students, this is bitline capacitance. Bitline capacitance meaning in bitline capacitance is nothing but we are sending the data, my dear students. Okay, we are sending the data, okay, via through these bits. Okay, we are sending the data through this capacitor. That's the reason it is called bitline capacitance. C bit equal to 1. There is a charge on the CS, and here also the bitline voltage V bit. It is also high. It is high. The bitline voltage is high because I had given the 1 here. Third one is that, my dear students, if C bit is low, C bit is equal to 0, I had given. Okay, so here what happens, it is reading 1 bit. Charge on CS means here reading of 1 bit takes place. When V bit is high, reading of 1 bit takes place. C bit equal to 0, discharge on CS, then automatically the V bit line becomes low. Then automatically what happens, my dear friends, reading of 0 bit takes place. Reading of the 0 bit takes place, my dear students. Okay, very important, my dear students. You need to remember over here. Okay, my dear students. Okay, so here ante ikkada what I am going to tell you, based upon this bitline voltage, you are going to give 1, means there is a charge on this one. Okay, then bitline becomes, V bit becomes high, then you can read once in the memory. How the reading of ones and zeros takes place. Okay, see, if bitline equal to 0, but this is constant, always the word line should be given as 1 only. Word line should be given as 1 only, my dear students. Okay, don't change this one. Don't change, my dear students, this particular one over here. Very important, my dear students. Listen over here. Okay, so C bit equal to 0, then discharge on CS. Okay, there will be a discharge on CS and V bit equal to low, the reading of the 0 bit takes place, my dear students. Okay, very important points you need to remember, my dear students, over here. Okay, very important points. Just I would like to bring it to your notice over here. Okay, now you got the idea how the read operation takes place, my dear students. Okay, similarly, okay, read operation takes place, my dear students. Okay, good morning, Aman Sharma over here. Similarly, I am going to explain, my dear students, the same concept with respect to the another operation, and that particular one is what? Charge distribution. Charge distribution or charge redistribution. For charge redistribution, what kind of the 5 equations you are getting? Very important, this one. For the charge redistribution, very important, my dear students. Listen carefully. This concept is very important for you. For charge redistribution, we need to ground this one, my dear students. Very important. This is the C bit line. Bit line capacitance, my dear friends, very important over here. Similarly, this is V bit line voltage, which are given, my dear friends. See here, this is volt line equal to 1. Volt line equal to 1, my dear friends, very important. The voltage CS, the voltage across this one is VS, my dear friends, very important one. See here, there will be the frequencies that while storing there is a certain frequency, and the current that is flowing through this, because here the capacitor is loaded, the current is this is load current here. You are having the load current, my dear friends, over here, very important. Okay, similarly here the two frequencies. Here what happens, my dear students, final voltages. The final voltage is VF. Here also you are getting the final voltage. The change in the voltage, whatever the change in the voltage that is taking place, and that one is final voltage. Okay, first take the circuit like this. Take the circuit, my dear students, like this. Okay, so first what I am going to do, my dear students, very important. Here the various parameters are going to be taking place, my dear students. Okay, now first when I am charging this one, when I am charging this storage capacitor, what is the initial charge on CS? First one is initial charge on CS. When we are activating this particular complete, that is one transistor. This is what only one transistor is there, so it is one transistor DRAM cell, my dear students. Okay, so initial charge on this CS, the initial charge on the CS, my dear students, the very important points you need to remember. The initial charge on the CS. Okay, and what is the initial charge on the CS, which is equal to QS is equal to CV formula, CS into VS, initial charge. Okay, now my dear students, and here what I am going to do, I am going to give the bits. Here I am going to give the bits, my dear students. Okay, now when I am going to give the bits, that is what happens, redistributed on this bit line capacitance. Okay, redistribute, because we are going to give zeros and ones. That's the reason it is called redistribution on C bit, my dear friends. Okay, until, so redistribution until there are certain conditions you are getting. Redistribution on the bit line capacitance until my dear friends, very that is see, we are going to get the C bit values on this one, whether are ones or zeros, until the conditions are there. The V bit, that is bit line voltage, and my dear students, this is the bit line voltage. Here what happens, the voltage across the storage capacitance, both are equal to final voltage. Both are equal to final voltage. Both are equal to the final voltage. We are going to do the testing like this. So we are distributing the zeros and ones. Okay, we are applying the logic zeros and ones until and unless the bit line voltage and the voltage across the storage capacitor will be equal to final voltage, my dear students. Okay, you need to remember this thing also. Now my dear friends, the very important thing, just I would like to bring it to your notice is this one. Okay, now here I want to get certain parameters, my dear students, over here. Now the term is that initial charge equal to, see here, now condition is here, initial charge this is the initial charge. This is 1, my dear friends. Okay, the initial charge, which is equal to, my dear friends, this is the final, the voltage across this capacitor, and my dear friends, the voltage across this bit line. So here the means the initial charge is equal to, that is charge across, that is CS, plus charge across bit line capacitance. So the initial charge is equal to the charge across this storage capacitor and this one. What is the initial charge? Initial charge is equal to what? Cs into Vs. So here Cs into Vs is equal to charge across Cs. This one. This Cs is equal to what? Cs into Vs. But what is the final voltage? The final voltage is Vf. Sir, here what I am going to tell you, this is also Cs into Vs, but Vs is almost all equal to Vf, final voltage. So I am writing final voltage. Okay. Similarly, this here, C bit into Vf, final voltage. Like that, my dear students, you are going to get the formula over here. Okay. This is the formula you are getting, my dear students, over here. My dear students, I am continuing the same concept here in the next page. So, what is the formula you are getting? That is also very, very important here. What is that one? QS. Whatever you are getting is CS into Vs, which is equal to, the formula you are getting is CS into Vf plus C bit, my dear students, into Vf. Okay, like that you are getting. Now, my dear students, take it. CS Vs is equal to, take Vf common. Vf is equal to CS plus C bit. Okay, very, very important over here. Okay, now this formula is nothing but the formula for charge conservation. Formula for charge conservation. Very, very important. This formula is called the charge conservation formula, my dear students. Charge conservation formula, my dear students. Okay, very, very important point. You need to remember over here. From this, bring back Vf outside. Okay, Vf equal to CS Vs divided by CS plus C bit, my dear students, which is always less than. Okay, this particular value, whatever the value you are getting is always, my dear students, which is always less than Vs. Whatever the voltage you are getting, final voltage is always, this particular one is less than Vs. That point you need to remember, my dear students, over here. Okay, so here Vf is typically what happens, my dear students. Okay, see there what we are going to take it. So always whatever the Vf value you are getting is always less than the storage. Okay, what the storage voltage. So the what happens, Vf is very, very, so as per the requirements, if we want to redistribute the charge on your, okay, in order to redistribute the charge, my dear students, okay, on this one transistor DRAM cell, always the final Vf voltage should be very small. And for EF voltage, my dear students, what I told you is typically very small, my dear students. Okay, very small, and requires a good sense amplifier. Requires good sense amplifier. Good sense amplifier, my dear students. Okay, like that you are going to get the various parameters, my dear students, over here. Okay, like that, my dear students, we have finished a DRAM complete circuit, my dear students. Okay, the complete DRAM, my dear students, we have finished complete. So in the examination, he will ask the question in such a way, explain the concept of DRAM and explain its working. Okay, the working principles. Okay, how to write, what is the DRAM operation, I told you in the previous class. Okay, so I told you in the, my dear students, in the previous class, in DRAM, what is DRAM operation? My dear students, I have finished. Second one is, the second one is, what is write operation takes place in DRAM? I have finished, my dear students. Next one is hold operation. My dear students, okay, good morning Krishna sir. And hold time, my dear students, TH. Okay, next one is refresh operation. refresh operation, my dear students. Next one is we have finished about the read operation. And last one is the charge redistribution. Like that, the different operations we have finished, my dear students. Okay, for the academic students of JNTUH, Kakinada and Anantapur, this particular concept is very important, my dear students. Okay, very important, my dear students. Okay, like that, we are going to get the various parameters over here. Now you got the idea, complete idea what is SRAM and what is DRAM, my dear students. Okay, very important points. Just I would like to bring it to your notice over here. Now we are going for the final. What are the differences between the DRAM and SRAM, my dear students? Okay, what are the basic differences between the DRAM and SRAM, my dear students? Okay, very important. Just I would like to bring it to your notice. Okay, very important, my dear students. Okay, Sharwari, Radhika, good morning everyone, my dear students. Okay, now see the very important things, my dear students, we are learning over here in a detailed manner. Okay, see here. The first point you need to remember, my dear students, is the DRAM. Okay, DRAM and SRAM. Okay, very important, my dear students. Okay, listen carefully. Here DRAM is dynamic RAM, SRAM is static RAM. You know that the dynamic RAM means it holds the data. It holds the data as long as the power is applied. SRAM is, my dear students, it holds the data. So here it loses its data when the power is removed. Okay, you know these things. But I am going to tell you some more important things, very important over here. Okay, in dynamic RAM, my dear students, it is the most commonly type of used RAM. Okay, most commonly used RAM. Most commonly used RAM, my dear students. Okay, DRAM is the most commonly used RAM in today's technology also. This is also used in ASIC, means application specific integrated circuit. ASIC means wherever the need is there only we are going to use, my dear students. Okay, used where? In application specific integrated circuit, my dear students. Okay, very important point, and just I would like to bring it to your notice over here. Okay, see here, my dear students, the very important thing is that always here what happens, any RAM is that, my dear students, we are going to use a memory cell in any RAM. Okay, in any RAM, my dear students, we are going to use what, my dear students? A memory cell. So here what happens in DRAM, my dear students, it holds, okay, each memory cell holds 1 bit of information. Right over here, each memory cell holds 1 bit information, my dear students. Okay, it holds the 1 bit information, my dear students. Okay, over here. But here what I'm going to tell you here, a form of flip-flop. So here I'm not using in SRAM the cells, I'm going to use a flip-flop. Okay, so that particular flip-flop only, my dear students, it is holding the data over here. Okay, it is holding a data, my dear students. Okay, so here completely different technology. We are going to use a different technology for SRAM. DRAM is a different technology and SRAM is a different technology. Okay, good morning Toshna. Okay, here what I'm going to tell you is, my dear students, here what happens, a form of flip-flop. My dear students, okay, good morning Shivani. A form of flip-flop holds, I am going to use, holds, my dear students, each bit of memory. Each bit of memory, my dear students. Okay, very important points, just I would like to bring it to your notice over here. Okay, very important, my dear students, over here. Okay, DRAM and SRAM structure is like this, my dear students. Okay, similarly, my dear students, here memory cells are used for holding the 1 bit. Here the flip-flops are used to hold the 1 bit of memory. Okay, similarly, here DRAM is made of only 2 parts. Okay, my dear students, it is made of 2 parts. It is made of 2 parts, my dear students. I told you, one is transistor. Now only you have finished the subject. And second one is capacitor. Second one is capacitor. Transistor, my dear students, and a capacitor I am going to use over here. Okay, here what happens, here we are going to use, my dear students, here SRAMs are available in different sizes. that is 4 DRAM, 4 transistors, 6 transistors. Already we have finished. మనం చదివాం కదా నాన్న, మనం డిఫరెంట్ టైప్స్ ఆఫ్ అంటే ఇక్కడ ఏం వాడుతున్నామో ట్రాన్సిస్టర్స్ వాడుతున్నాం, డిఫరెంట్ 4 transistors, 6 transistors ఇక్కడ. So here what happens, the transistors along with some wiring. Okay my dear students, I am going to use transistors along with some wiring. I am going to use some wiring, my dear students. I am going to use here, my dear students, over here. Okay, very important points. Just I would like to bring it to your notice over here. Okay, transistors along with the some wiring, my dear students, I am going to use here. Okay, and dynamic run, it is refresh. You can refresh, my dear students, by using the refresh circuitry. Okay, here it will be never refreshed, never refreshed, my dear students. Okay, very important points, my dear students. Okay, and when it comes into the C, here I am going to use the transistor and capacitor, only one transistor and one capacitor. Now tell me, my dear students, if you know the answer, tell me, there is no issue. See, DRAM and SRAM, if you are comparing, in DRAM I am going to use one transistor and capacitor, but in SRAM I am going to use the transistors, so many number of transistors. Now which one is cost? Type the box, no problem. Type your comment. Which one is costly? Which one is more expensive, my dear students? Which one is more expensive? DRAM or SRAM? Because here what I am going to tell you, my dear students, is that I am going to use the two parts, transistors and capacitors. Here so many number of transistors are using. That's the reason the DRAM, okay, is because I am going to use only less components, so it is less expensive. And less expensive, it is more expensive. Okay, and moreover, my dear friends, here what happens, because of using the transistors, more number of transistors, all the transistors are NMOS, maximum NMOS. We are going to use CMOS technology. We are using the CMOS technology. There is no problem, my dear students. Okay, so because of the transistors, the SRAMs, okay, the what happens are faster. The SRAMs are faster in speed. That is nothing but it works in faster. And DRAMs are slower devices. DRAMs are slower devices, my dear students. Faster and slower devices, my dear students. Okay, and here we can access, what is the time of access for DRAM and SRAM? Okay, the time to access the DRAM, it takes only, my dear students, 60 nanoseconds. Access time 60 nanoseconds. It is more faster. So if it is more faster means we can access in very less time. We can access in very less time. So here access time is, my dear students, is 10 nanoseconds. 10 nanoseconds, my dear students. Okay, like that we are going to use over here, my dear students. Okay, very important, the parameters, just I would like to bring it to your notice over here, my dear students. Okay, and similarly, okay, when it comes into the speed also, when it comes into the speed, the how much the circuit is running speed, my dear students, those particular parameters also very important. Okay, so see here where access speed is taken into account. See, SRAM is used, my dear students, when we are going for the access speed. Okay, so when we are access the more speed, if any, okay, based upon the speed parameters, SRAM is preferred. Okay, based upon the speed parameters, SRAM is preferred. SRAM is preferred, my dear friends. So here, based upon the speed parameter, DRAM is not preferred. Like that, my dear friends, you are going to get the various parameters over here, my dear friends. Okay, so all these things are pretty important, my dear friends. You need to remember over here. Okay, you need to remember, my dear friends, over here. Okay, so here there are certain other parameters also. Just I would like to bring it to your notice over here. Okay, see, I am going to tell you those particular parameters over here also. Here, what are the capacitors I am going to use here, my dear friends? It holds here. It holds the 1 bit of information. See here, what are the capacitors? Because in DRAM, I am going to tell you the capacitors and the transistors. Listen carefully. And in DRAM, the capacitor is holding that particular bit amount of information. That bit amount of information, whether it is a 0 or 1, whether it is a 0 or 1, the some other miscellaneous points I am telling you. Other miscellaneous points I am telling you over here. ఇక్కడ ఏం చేస్తుందన్నా, the capacitor ఏం చేస్తుంది, capacitor is holding that 1 bit of information, whether it is 0 or 1. Okay, so the transistor acts as a switch. ఇక్కడ ఏమైతే DRAM లో the transistor is acting as a switch that lets the control circuitry on the memory to read the that is contents of this particular. So this transistor is reading the contents of this capacitor. Okay, but it is holding either 0 or 1 only, my dear students. Okay, in that particular one, here what happens, that's the reason here the capacitor is acts like a small bucket. ఇక్కడ ఏమైతుందన్నా, DRAM లో capacitor is acting as a small bucket. ఎందుకో కెపాసిటర్ ఏంది మనకి ఏంది DRAM లో నేను చెప్పాను కదా, మనం ఇంతకుముందు దాకా మనం సర్క్యూట్ చేసాం. ఏం చేసాము, కెపాసిటర్ ఈస్ హోల్డింగ్ ద బిట్ ఇన్ఫర్మేషన్ 0 కానీ 1 కానీ. సో ఇక ట్రాన్సిస్టర్ ఈస్ యాక్టింగ్ యాజ్ అ స్విచ్ దట్ లెట్స్ that is letting the control circuitry at word line is given 1, it is reading the contents. If it is 0 means it is not reading. Okay, so on the memory chip to read the capacitors and changes its state. Okay, here what ultimately here capacitor is acting as a bucket. Capacitor, my dear students, this capacitor is acting as a small bucket only because we are doing the periodical refreshment. Small bucket, my dear students, because we are doing the periodical refreshment, my dear friends. Okay, it is a small bucket because it is storing only that is 1 in a memory cell. 1 in a memory cell, that's the reason it is called a that is small bucket. Okay, if it is 1 is present in the small bucket, it means that my dear friends, in the bucket means here it is filled with electrons. If 1 is filled, so if the capacitor is a small bucket, if it is acting, if it is filled with my dear students 1, to store 1 in this particular bucket, the meaning is that it is filled with electrons. Filled with electrons, my dear friends. Filled with electrons. Okay, if it is 0 means, if you want to store 0 means, my dear friends, it is emptied. It is empty bucket. It is empty buckets. These are all the points, or the miscellaneous points you need to remember, my dear students, over here. Okay, very important points, just you need to remember, my dear students. Okay, so but what is the problem with this capacitor bucket? It has leak. It has leak, my dear students, because here what I am going to do, my dear students, is continuously what happens, the refreshment is going to be happening, my dear students. Okay, very important things, just you need to remember over here. Okay, see here what I am going to tell you. So the finally these are all the comparisons, just I would like to bring it to your notice over here. Okay, so in the next class, my dear students, I am going for the very important topic. Okay, and that particular important topic is that comparison of the various types of memory elements. Memory elements means SRAM, DRAM, that is masked ROM, programmable read-only memory, erasable programmable readable memory, E-square PROM, flash PROM, like that. Okay, every memory is there, my dear friends. We have to study all the parameters in the next coming class. Next, why we are preferring the why we are preferring, my dear friends. Okay, that is SDRAM, means synchronous, that is dynamic random access memory, because we have finished about DRAM gurinchi chadivam nana. Similarly, we need to study why we are going to prefer the synchronous, that is dynamic random access memory. Okay, and what is the difference between a DRAM and SDRAM? that I'm going to bring it to you into the next class, my dear friends. And I'm also bringing to you about the what is the SIPO is the serial in parallel. It is over. Next parallel and serial out is I'm going to finish in the next class. And similarly, I'm entering into the performance matrices. After performance matrices, because what are the memory performance matrices, my dear students, all those things I'm going to explain in detail manner in the last class, because this is very very important. On this one only I have done my PhD, okay, that is thesis or research in VLSI, okay, on the projects, okay. My project is on this performance matrices in VLSI in research side, okay. Similarly, finally, okay, next class I'm going for the last unit. And the last unit is very very important, that is semiconductor integrated circuit design. Every morning class is 9:30 to 10:30, okay, in between weekdays as per your, that is college timings, but in weekends you have the timings, my dear friends. You have the timings Saturday and Sunday also there, same timings 9:30 to 10:30, same timings 9:30 to 10:30 in Saturday and Sunday also, my dear students, okay. Very very important over here, okay. Finally, as I told you that the number of followers in the Facebook is day by day is increasing as far as Unacademy is concerned, okay. My dear students, the very very important points just I am going to bring it to your notice. And one more important thing itself is, my dear students, for some of the college academic students, I am going to start electronic measurements and instrumentation semester subject in the special class in the app in evenings. In evenings, my dear students, till this just brushing of the subjects of parameters, my dear students, okay. For the some other college students also, I am teaching the EMI for the final year, some brushing of the fundamentals. If you want it, you can attend. Similarly, the Unacademy GATE English channel, you are going to access the various subjects in the medium of English only, my dear students, okay. Finally, thank you. There are other channels also there. You are going to access these channels and learn the different subjects for the different competitive level examinations, my dear students. And finally, thank you very much for attending the today's session. Thank you, my dear students, for attending the today's session, my dear students.